Dear friends, today's topic is translocation, heterozygote, and gamete formation. For this purpose, two sets of chromosomes are involved. One chromosome is having centromere A and another is having A prime. These two are homologous, having the genes one in left hand arm and two in the right arm, and at the same time another pair of chromosomes are involved, and these are having the genes 3 and 4. Chromosomes having centromere A prime and centromere B are involved in the reciprocal translocation from the second chromosome. Gene 1 is shifted to the third chromosome having centromere B, and at the same time from the third chromosome gene 3 will be shifted to the second chromosome which is having centromere A prime. Thus, in a translocation heterozygote, two normal chromosomes and two translocated chromosomes are observed. These translocation heterozygotes are formed in prophase 1 of meiosis 1, and they form a plus-like structure in Pekitin configuration. So, these chromosomes are involved in the formation of translocation heterozygote. Okay? And they will form the peculiar plus-like structure in Pekitin configuration. So, this is the peculiar plus-like structure of Pekitin configuration where 4 chromosomes are involved. Okay. This is the structure. This one is the first chromosome having centromere A and gene 1 and 2. It will pair with the third chromosome in one side having gene 1. This is the third chromosome, B centromere, gene 1 and 4. This is the second chromosome having A prime centromere. 2 will pair with 2 and gene 3 will pair with 3 at the bottom. This is the fourth chromosome having B prime centromere and genes 3 and 4. 3 at the bottom and 4 at the right hand side. Thus, such a peculiar plus-like structure is formed in Pekitin configuration, which is involved in the formation of gametes. This is the plus sign. And they will follow 3-way for the formation of gametes. Okay, and these are adjacent 1, adjacent to, and alternate. In adjacent 1 segregation, the two non-homologous chromosomes lying adjacent to each other move to one pole, while the remaining two move to the opposite pole. First of all, they will form a ring-like structure with the help of the 4 chromosomes. This one is centromere A, B, B prime, A prime. And genes are 2, 1, 1, 4, 4, 3, and 3, 2. So this is the ring. First one, third one, fourth one, and second one. So this is the ring. So it is in anaphasic movement now. So this is the pole and this one is the pole. Two opposite poles. Okay. So to the upper pole, the upper 2 chromosome, and to the lower pole, lower 2 chromosome will move to the formation of the gamete. So first gamete having centromere A and centromere B with the genes 2, 1, 1, and 4. Okay. Here 1 is duplicated and 3 is deleted. So 3 is deleted and gene 1 is duplicated. So due to deletion and duplication, these two gametes will be non-viable or sterile. Okay. So sterile or non-viable. Now for the second gamete, the lower 2 are involved here, having the centromere A prime with gene 2 and 3 and centromere B prime with centromere 3 and 4. So 3 is duplicated and 1 is deleted. So gene 3 duplicated, gene 1 deleted. Hence, again these are non-viable or sterile. So in adjacent 1 segregation, non-viable gametes are produced. In adjacent 2, here again the adjacent chromosomes are involved in the formation of gamete. Okay. So the chromosomes at the left hand side, they will go to one pole, and the chromosomes to the right hand side, they will go to the other pole. So for the formation of first gamete, the chromosomes involved are A centromere and A prime centromere. Okay. Having the genes 3, 2, 2, 1. Okay, so these two are involved in the gamete formation, and here the gene 2 are duplicated and gene 4 are deleted. Again, due to deletion and duplication, they are this gamete is non-viable, and the chromosomes are also non-viable. Similarly, these two chromosomes are involved in the gamete formation, having the centromere B prime and B with the help of genes. Here genes are 3, 4, 4, 1. So 4 is duplicated and gene 2 is deleted. So again, due to deletion and duplications, the chromosomes are non-viable. Hence, the formed gamete is also non-viable or sterile. So, in both the cases of adjacent segregation, non-viable or sterile gametes are formed. So, the adjacent segregation is involved in the gamete formation in last case. Here, the alternate chromosomes from the ring are involved in the formation of the gamete. For this, they must be twisted. The right hand chromosomes must be twisted to form a 8-like configuration. This is the 8-like configuration. In the left hand side, the two chromosomes having A and A prime centromere are involved, and in the right hand side, the chromosomes are twisted. Okay, the lower chromosome is now at the upper side and upper chromosome is now at the lower side to make the 8-like configuration, having the respective centromeres and genes. So these are the respective genes and they are arranged in this manner in the 8. Now I am going to draw this one is elaborately. First chromosome of the left hand side, upper one, second one of the left hand side of the lower one, and this one is the next part where the two chromosomes are twisted. So this one is first chromosome having centromere A, this one is A prime, this one is the gene 3, and here the respective genes. Okay, so this is the last configuration, and here the chromosomes are involved in the gamete formation. For the formation of gamete, the upper two chromosomes are involved. Okay, this one is the first one chromosome and second one is, these are the centromeres, and here the genes are 1, 2, 3, 4. All the genes are present. Okay, there is no duplication as well as no deletion. Hence, these chromosomes are viable At the same time, the viable gamete is formed. Okay. Similarly, okay, this one is the viable gamete. Similarly, for the formation of second gamete, the lower two chromosomes are involved. This one is one chromosome with its respective centromere and genes. Second one with its respective centromere and gene, where all the genes, that is 1, 2, 3, 4, all the genes are present. That is, there is no deletion as well as no duplication. So 1, 2, 3, 4, all the genes are present. So the gamete is viable. Okay. So by means of alternate segregation, viable gametes are produced, but by means of adjacent 1, adjacent 2, non-viable gametes are produced.